elements. So today's outline, we will review the exercise 5 a little bit and then go into elements of regional decision maker. RDM is a platform which is being built to support regional planning, and it has additional data other than industry and occupation cluster, and then a bit of background on regional food systems, Indiana's food system infrastructure, and then in RDM, Andre will show you the farmers market mapping tool that we have been developing, and then some discussion on exercise. So for webinar 5, we only received one response, which is fine. Means we will post all the answers to these exercises later. There is one typo in that exercise is in the question numbering. Question number 2 is not there. However, the importance of webinar 5 is that it is a similar type of analysis which you had done for industry cluster. And the purpose is that whenever you are analyzing a region, you need to look into industry cluster as well as occupation cluster. And both the information, both sets of information are important. So with this, let's go into the elements of a regional decision maker. And there are 6 elements you can see from the graph, the chart, that we are focusing on. And in industry and occupation cluster, as we have shared, there are 3 mapping websites. The food systems that we are developing, there are 2 separate mapping websites. So one is focused on food infrastructure, such as farmers market, that we will be demonstrating today. And another one is more related to logistics, transportation, and food movement of processed food. And we will be discussing that in the next webinar. And then we have transport and freight related assets, the basic data on regional transportation, land cover and land use, that is also under development, natural resources assets, and then mapping websites for basic demographic and economic attributes. There are a couple of websites which we are developing in this area, because as you know that demography and economy it's an extensive subject, and all the data sets, all the mapping websites, we are using public data other than industry and occupation cluster, where as you know that we have a partnership with EMSI. Now these public data set we are of course processing, analyzing, and doing some value added work before we develop maps and charts from them. So let's start with community and regional food system. We are all aware of conventional food system. This is what it has been existing in regions and the nation, and corporations, agribusiness, distributor, these were the main stakeholder. These were the supply chain for the conventional food system. But community and regional food system is a new phenomenon, relatively new phenomenon which has been occurring, and it has gained a very extensive footing. A lot of comprehensive planning and regional planning efforts, they are now recognizing food system as one of the important element. In this case, the stakeholders are really different. Means we are talking about farmers, consumers, and households. But important thing is the source and origin of the food are known, which we never used to know in the conventional food system. When we used to know that we were getting strawberries from Holland and bananas from Peru or some South American country. But in this case, we in the local and regional food system, we definitely are more aware of the source, origin, and how it has been grown or processing of the food. And it is a sort of movement which is taking place in community planning. It also has a role in mitigating food desert effect. You might have seen the USDA research and websites on identifying food deserts. There are various criteria, and food system, developing the regional food system is one of the way to tackle it. And then, of course, the public health angle of a regional food system is very important. Another important element which has been emerging is public health, whether we look into regional planning or community planning, and also in transportation. Public health is now the next frontier for transportation planning, and really to analyze how each of these projects and emissions they actually, and planning means lack of sidewalks and elements for physical activity affect the general public health. So what we have done here is we have taken a definition from a paper which came out in the magazine Choices, which is the Agricultural Economics Journal, and there they say, the Clancy and Roof, that an ideal regional food system is about as much food as possible we can grow and meet the population demand, the regional population demand, the regional population need, and the production, processing, distribution, purchasing, all this should happen at multiple level and scales, but within the region. It should be resilient, and minimum importation means that you are importing as little as possible so that there is less economic leakage from the region. And in general, it should have it should give some significant economic and social return for all stakeholders. Now, important thing is self-reliance and not on self-sufficiency. And this criteria becomes important when we look into food sheds, which we will be covering in the next webinar. To delineate food sheds, there are some research happening, like what kind of area a region needs based on the diets and other criteria to grow their own food. And it is in transportation, we say this as an optimization problem. But then if you add the criteria of self-reliance versus self-sufficiency, the whole problem can become very different. So the important thing is about self-reliance and not like 100% self-sufficiency and something like that. Food system planning, the way we look at it, it is connected to almost every element of the community and the region. We are talking about transportation. It does affect transportation and is affected by transportation planning. Public health, it is directly related. It is also addressing equity, especially the food desert. Then green infrastructure, which is a very important element emerging. Green infrastructure, food system is directly related to that. The land use, by land use here we mean land cover. The regional economy and community economy, of course, and then it is about sustainability. So food system is such an important topic now that it is intersecting almost every community comprehensive plan element which we used to do before. Now, if we look into the history of food system planning, the emphasis has actually emerged recently, not only in USA but also in the United Kingdom, because the two articles that we are referencing in the second bullet point by Kaufman and Nicole, these were written in the same year in the United States and United Kingdom, and the main point was that the planning practice is not recognizing food system as an element. But however, in the last 13-14 years now, we look back and we can say that there are dozens and dozens of regional and local food initiatives across USA, and even the World Watch Institute, they have been writing about it and they have been documenting it. So you can go later and in this URL, in this link, and you can look at it, like how 25 US states, what kind of innovations they have. Indiana is also mentioned there. Then NIRPC, local food study, the NIRPC regional plan, they have a regional food element. And then of course state of Indiana had a large study on the emergent food systems. So the food system is being studied at various scales, means community, region, statewide. So it is becoming very important. Now this slide has been borrowed from American Planning Association, and this defines various components for the food system. So production, of course, production, processing, distribution, consumption, disposal, all the basic elements which are there. But the important thing is, if we are looking into community, local and regional food system, then there is an opportunity to have a cyclical process, so that the disposal and the waste product and compost and all these things finally loops back into production process. In the field and the agricultural field, which was very difficult to track in conventional food system. It was not possible. So lot of food and lot of waste product, means tons and tons. There is a metric here by United Nations that in US about $165 billion of food is wasted every year. And by food, this means these are cooked food, semi-food, means they have become bad from restaurants and everything. So it's a huge waste. But community and regional food system, we can build in, we can look into processes where some of these disposal can look back as organic manure and compost and back into the production. Now within each of these elements, we can look into infrastructure, and that is what this webinar will be about. Is we will be focusing on a specific infrastructure. So for in production, if we look into production, then you will have to document, map and do an inventory of where are the community supported agriculture farms, where are community gardens, urban agriculture if they are happening, aquaculture, hydroponic, greenhouses, and of course the conventional agriculture. Now in conventional agriculture, we have significant amount of data and information available through NASH, which is the National Agricultural Statistics program, and they have satellite imageries from where you can know pixel by pixel which kind of food is grown. But for other elements, the database are still under development. And then in processing, if we are talking about regional food system, then of course the conventional processing is there, which was part of the conventional food system, but then these small scales, cooperatives, where are the cooperatives and food hubs? But this is another term which has emerged, food hubs, you will have to know for your region. And then of course for distribution, farmers market, there are drop-off sites for community supported agriculture, cooperative, various kinds of stores and pantries. So all these elements, as APA listed, they are the infrastructure, means they are related to these major buckets like production, processing and distribution. And within the food system planning, a lot of terminology has also emerged, and we will cover that in the next webinar, like food miles and farm to fork and what all these mean. But then here we will talk a little bit more about food hubs, which is very important, and it is also gaining quite a bit of ground. Means lot of community and regions are now looking into establishing regional food hubs. One advantage of food hub, means for a regional food hub or a local food hub, is it can perform a multiple function, but it is actually serving most of the cases your region. So it's a centrally located facility, and it has quite a few of operations, means aggregation, storage, and all these, mostly focus on serving your region. And then in 2012, according to USDA, we had 168 regional food hubs. So as part of the RDM, what we are trying to build now is the last slide when you saw all these different kinds of infrastructure, the inventory of that. We are trying to build that, collect those data, analyze those data, and trying to build mapping websites for you so that your analysis, it will be easier for you to do your regional analysis. So in this context, I should talk a little bit more about the research which is happening in the area of food hub. So for example, Penn State University, they have been really building some optimization algorithms on how to locate a regional food hub based on criteria, based on different kinds of criteria, and that includes your processing, production. There are quite a few elements, and that research is under progress. Similarly, University of Chicago and of course Penn State University in collaboration with Columbia University, they all have been doing research on how to delineate food sheds. And then of course Chicago, when they did their research, it was for the Chicago metropolitan region, but then they also looked into other Midwestern areas. How do you delineate food sheds based on the production capacity of the land and some assumptions on the dietary needs. And as I said, that these are optimization problems. Means these come from the area of operations research. Means these are mathematical tools, but then they can be interpreted and integrated with the GIS. So we are also trying to do a literature review on what kinds of other research which is happening, and which we can bring it to our tools so that we don't reinvent the wheel. So going ahead, I will just share some of the examples of spatial analysis. So for example, there were 168 farmers market in 2010 in Indiana. Of course, now it has increased. Andre will share with you the data for 2012. But here what you see is these are, again, as I said, these are the NAS statistics, the land cover data, and the level of detail, the pixel by pixel level of detail, what kind of food, crop, grain are being grown, it can be tracked. These, these white lines which are delineating, or in some cases the farmers market is right in the middle of that, we call these as Thiesen polygons or Voronoi diagrams, and these are first step in analyzing the natural market area. Now here we are not considering any transportation element to that. That comes at the next level. But when you start mapping these elements, these infrastructure, then you start looking into it, like what kind of area they are eligible to serve. Of course, for rural areas, it can be much longer. So these are just some of the starting point of spatial analysis, which is required, which is recommended by American Planning Association on how you can proceed with analyzing your infrastructure that you have. And then, of course, you can also relate it with your population density. These kinds of data is available, but these kinds of all data are there in RDM, and we are developing it more. So these are just some of the examples. So by typology, by product type, and of course we can see here the distribution of farmers market by product type also is quite related with the population distribution. And then here is another example of full and limited service restaurants. Thousands and thousands of these are there in Indiana, and of course in any state. And these are from Dun and Bradstreet database. But then of course when you have you have a data at such scale, you can do various kinds of spatial analysis with respect to population density or various kinds of distance-based rings or regions. And Andre will be showing you and sharing with you other kinds of tools, which are their dynamic tools, which have been integrated with the RDM. So with this, I will ask Andre to start with the mapping tool, which is, we call it as FIAT, which is Food Infrastructure and Analysis Tools for the RDM.
Thank you, Indranil, and good morning, everyone. So I will start demonstrating our website. Let me open the window. Is it Mozilla?
Yeah.
Okay. So I'm going to our original decision maker page, and let me pull it to the screen. Okay, so now everyone can see that. I'm going to our GIS Atlas section, and here you can see Farmers Market link. So this link opens web application related to farmers market and food infrastructure in general. Right now, the layers that we have on this web application are farmers markets, piece and polygons, and industry cluster data available for 3 years. So first, let's look at our traditional tools that we have. And again, this is a very similar outline and structure of the web application that we showed before for industry and occupation clusters. So you have the same navigation elements, the same menu with tools on the top, and same layer list on the right. If you like, you can always open Legend and see what are the icons, but also you can see those in the layer list too when you click on the arrow and open the information beneath each layer. So right now you're looking at locations of farmers markets in the US, and this database is actually a USDA database of farmers markets, and this is self-reporting database. So these data are not collected by this agency. It's self-reported by people who are interested in this. So for the entire United States for 2012, the number of farmers markets was about 8,000 markets for the US, and we have, I think, we included it includes Hawaii, Alaska, and Puerto Rico. So let's zoom into Indiana. And again, what we have here is a set of tools that allows you to navigate on the map, like zoom to state, Locator. Now let me open this Locator tool and explain what it is. It's basically the tool to locate any address in the whole United States. So if I enter any address, our address is 2101 Martin Tishke Drive, West Lafayette, Indiana 47906 907. And let's see if we can find this place. Here we go. So it shows the campus location, and actually it shows you different versions of that. So it's similar to Google Map. You can find any address, And this is when you want to find either your own location or location of farmers market that you know, or any other location. So this tool can be useful. You can also obtain geographic coordinates for this point. All right. So next tool is add graphics to the map. Again, this tool was shown you before, and this is to draw anything additional on the map, on top of the map, like area of your interest or labels for that area. And then you can save these graphics. Let me quickly zoom out and demonstrate this. So right now I'm in polygon mode. I want no color. Actually, I set alpha value to 0. That means my polygon will be transparent. But outline color, I pick red color, and I set alpha to 1, which is fully opaque, and set width to 4 points. Also, you can do measurements if you want to measure your area or length of distance, for example. But I don't want this in this case. So I start drawing around my area, say around Lafayette. Okay, and then I can save these graphics on my hard drive, and then when I come back later I can load this area and also labels if I want to. For labels there is this option add text, so you switch to that and you can add some text, area of interest, for example. I want red color too, and maybe a little larger font, bold font. So I click, and the label, the center of the label will be at the point where you click, right here. So I can save these graphics and then come back later and load these graphics and use it, for example, to print my PDF map or image for report. Next, again, there is a print map tool that allows you to print either PDF or save it as any of these image formats that you can use in your PowerPoint or Word file. Insert them. You can give title to your map, authorship, copyright note. So I won't be printing this right now because this tool was shown you before. Upload shapefile tool. If you have any geographic data you want to upload, point data, line data, or polygon data, you can do it here. Again, I don't have it right now on my hard drive to demonstrate, but this is your local shapefile should be zipped because shapefile is actually a collection of few system files, and people who do GIS know that. So you zip those files into one single zip file and load it here, and you can also change the way it looks, and you can actually right now with this version you can change it after you load your file. So you can modify fill color, outline, you can add labels from attribute tables of that file, which is useful if you have already some geographic information that you want to use on this map. So now let me show you a specific tool. First let me demonstrate information tool for each farmer's market. Whenever you click on any of these points, you will get information for this specific farmer's market. Street address, location type, hours, produce, and website if it is available. Sometimes, like in this case, this is the repetition actually. It's a redundant record. And this is again because this database was self-reported. So Many data are either redundant or actually sometimes not geographically correct. We did our best. Actually, I went through and corrected those outliers or records that were redundant, but still some leftovers remain in this database. But anyway, you can get information about each farmer's market, which is convenient. Especially, you can see produce that this market sells. Let me click on anything else. Like for example, here for this market, data not available. So this data was not entered into database, neither hours or location type. But there is a geographic address and website. So it depends on what kind of market is out there. Some markets are very seasonal. Some of them are pretty consistent throughout the year. Some develop better. Some just some rudimentary information, because I was checking some of the websites while doing those geo corrections. So we created a geoprocessing tool that helps you to identify farmers markets within a certain distance from your location. So this is the icon that opens this tool, Find Farmers Markets. You click on input point and you enter distance. So this is radius from that point that you want to look at. Right now the default set to 50 miles. So let me click, let's say north of Indianapolis. So I set my point, I click submit, and the tool takes all farmers markets within this distance and marks them on the map, and also produces attribute table. So this table is a list of markets that fall into that area. Now it's a little hard to see all data from attribute table here on the screen, but there is an option of copying those data and pasting them into Excel file, Excel spreadsheet. So you just click on this icon and it copies this to your clipboard, and then you open Excel and paste. Well, let me demonstrate that straight away. So I'm bringing my Excel spreadsheet here. So I clicked on that icon right here next to the list of selected farmers markets, and now I am do paste into Excel spreadsheet. So here we go. So if you need this data later, you can always manipulate with this data and save those in your spreadsheet. You can, on the screen, in this pop-up window, you can sort data by any field or column that you have, for example, by county or by produce type, if this is available, or by schedule. There are some other additional information for each market, like if they accept cash or governmental help. So there is some information about each market here. The other tool that is useful is calculate drive time, and this is just to give you an idea what markets are located within a certain distance or drive time from your location point. So again, I'm opening this tool, and I click on this point mark and put this point anywhere on the screen. So this is suppose my location, my home. And drive times right now, they are not changeable, 5, 10, and 15 minutes. So I can see only those markets that are within this drive distance from my location. So it takes a few seconds, and now you can see yellow area is 5 minutes, orange area is 10 minutes drive distance, and pink is 15-minute drive distance. So I can see that those several markets, actually just one is within 15 minutes drive from my my home. Again, you can close that, as with any tool, you can close this tool and then open it, and it will save, it will still keep those results on the screen. Next tool that can be useful is find route tool. This is, for example, when I want to find best route from a place where I live, for example, this town, and nearest farmer's market, or the farmer's market that I want to go to, say right here. So it calculates the route. Actually, you can also view directions. Let me switch to directions here. And you can print actually map and directions using this printer. So I can check include map. I can, and I'm clicking save PDF, and here let me put it on a desktop. So it should be ready now. So let me check. So this is how this PDF file looks like: map and directions, how to get to the place. So this is pretty similar to what you use in Google Map, for example. And yeah, Indranil reminds me that there is a barrier tool. For example, if you for some reason want to go around some area, you can always enter barrier. So there is a button here at the bottom of this pop-up window, add barrier. So you click on that, and I am choosing this option so that I can click on the map. So I'm adding barrier on this road. For example, there is a construction, or I don't want to go there for some reason. So then it will recalculate the route again. Okay, does it? Okay, let me start over again. So I click on those two locations. I'm adding barrier, maybe right here.
Yeah.
Yeah, right now it's rerouted me to a different road. So this is how you can manipulate with this tool. So this is right now. Yeah, there is another. Actually, I forgot to show you another layer, industry clusters, and actually this is what you saw before for industry clusters web application. So these are employment numbers for agribusiness and food processing cluster. So there might be actually some correlation with farmers market, but not necessarily. It's just for your information to analyze, the whole situation in your area. And one more thing that I want to explain is Thyssen polygons. As Indranil explained, these are polygons. This is a area of market influence. This way, probably when you plan maybe location of new market, or studying the market for a new location, you can look at how dense is this area with farmers market, and where is the better location for a new market. So each line here around each market is drawn approximately in the middle of a distance between nearest farmers markets. For example, this market in Frankfurt and West Lafayette, the line is drawn somewhere in the middle. So it separates those areas, kind of areas of influence of those markets. So this is all that we have right now, but we plan to add more infrastructure, food infrastructure to the web, our web application, to our system, like grocery store locations or hub distribution centers, whatever we can find or generate data, we'll add here. All right, with this, I'll pass my word to Indranil.
Yeah, thank you, Andre. So what Andre has been showing is the database that we have developed for farmers market. What is in progress are we are trying to search data for community supported agriculture and regional food hubs. And then there are some additional network based tools which we are developing, and in the next webinar which is more focused on processed food movement in the United States, we will be sharing some of these tools. Now, here what Andre had shown, the travel time tool, 5, 10, 15 minutes, that we have been accessing through ESRI, but we are also building our own network tool which will give you freedom to change the travel time and travel distance, and we will be demonstrating those in the next webinar. Why these Thesians and Voronoi polygons? Just wanted to share a little bit. They might look a theoretical approach, and which is true, but the reason we have given it here is so that at least it can give you a starting point for the influence area or the area of coverage. From that, either it can be farmers market, and for a regional food hub it will be very different. Now these polygons will look very different if when we are adding the transportation side to it, or may look very different when you add some demand side layers like population distribution as the background, and then run those as a weight to determine these polygons. So this website is currently under development. As I said, that this system we are still developing. So as we add new data and layer, we will get back with you new tools. The barrier tool, what you see here, the find route and barrier tool, that is based on the default NAVTEC data. And there is importance to it, because you can add a stop barrier, a point barrier, or even draw a line across a barrier, and the tool should recalculate. So this particular website, the food infrastructure, we will try to bring in as much infrastructure element as possible. Farmers market, and as Andre has said, that because this is self-reported data collected by USDA, and when we try to geocode them, we found some mismatch, and we try to take care of it as best as possible. So when you select in a particular farmers market, and this is what I wanted to show you. So you will always find there are two selections, and one is for this farmers market, which is the point location, but the other one actually selects that polygon, and maybe I am able to show you. So that's the Voronoi diagram, or the Thiessen polygon we call it, and the reason is because it is tied to it. This area of influence, when we will run it for regional food hubs, will look very different. But the thing is, all the analysis of land cover means and the NASA statistics the Thesian and Voronoi polygons can be the starting point for that. Now another explanation is, in the raster format they are called as Thiessens. They are used heavily in atmospheric sciences, but in another way, when we call it as Voronoi, which means that every point within this polygon is nearest to this farmers market. There is another way of explaining this thing, this particular analysis. And of course, this area changes based on your coverage. So the map I showed for Indiana, that was only for analysis, analyzed for Indiana, now it is for whole of USA. So this website will be improved, will be having a lot of additional data which we are processing. The industry cluster data, we have already added agribusiness, and that's important because farmers market and all these are associated with agribusiness industry cluster. We will be adding the occupation side also. So as you know that in the occupation cluster, we have an occupation cluster element on food processing technicians, because these are such specific type of occupations, they came out as separate occupation cluster. So with this, we will be ending the demo for food infrastructure analysis and tools. For the next webinar, it will be on processed food movements, and we will be demonstrating quite a few tools there. The broad regional analysis of how the food is moving, what are the logistics infrastructure which are participating in that, and then some of the transport network based tools that we are trying to develop in-house. So as I said, that when we develop all these tools in-house, then we can give freedom, so you can change your travel distance and do the analysis. Now, one thing important: farmers market, regional food hub, these data sets are very dynamic. Farmers market, they open, they close. So we are thinking of building a geocoder here, so that when you have your own data, you can geocode and bring it on top of it. The shapefile is another way of bringing the data. It does not come to our server. With this, we will be opening it for any questions. Any question you have, any comment, or any further detail you want to know, please let us know. Any question on regional food system, farmers market database, anything? If there are no questions, then the next step will be that Andre will be sending you some very simple exercise. These exercises won't be as complicated as industry cluster or occupation cluster exercises, and hopefully you will be able to do that really fast. I will again request you that please complete the occupation cluster exercise if you find time, and then there is one errata, one typo there, and that's like, it's the question number 2 is not there, so it's question 1, 3, and but that's fine. You can answer it, and then we will be posting the correct answers on the website. And the idea is that with these exercises, answers, and webinars which are getting recorded, uh, there should be like a complete module available for regional analysis, and which will be also useful to you in the future, or anyone, any new planner or analyst or GIS analyst who can go through step by step and will be able to use the RDM website. With this, I will again be opening for any question, comment, suggestions. Yeah, the question is, how can farmers market that aren't on the map be included? And that's a very good question. That's what I was saying, that this data is so dynamic that farmers market get closed or they open, or sometimes the self-reported USDA data does not cover. There are two ways. If you have your own shapefile and your GIS person will know about it uh, easily, and shapefile is the simplest GIS file, and uh, and it's an open source. So you can use the tool here, upload shapefile, and you can actually upload your own shapefile here. Let me see if I can upload just one example, and I have some examples here. I have some example from Oklahoma. I have some example from NIRPC, but let me see. Say ECI RPT boundary zip. I have polygon example, but actually you can also add point data, and hopefully you are able to see here whether it is polygon, polyline, or point data set. If you have your own shapefile, you can straight away upload it here. It does not come to our server. However, you can use this as your background to run the analysis. So I can give an example for a very quick study for Iliana corridor, which is not part of any transportation network. We got the SAFE file, we brought it on our industry and occupation cluster website by using this upload shapefile tool, and straight away ran the analysis by using this as a background. So that is one way of bringing your data here. And this is true because farmers market is a very dynamic very dynamic type of data, and there can be other data sets also. So, and then another way is that geocoder tool I was mentioning. We are building that capacity. So by the geocoder, you should be able to, if you have address and everything, you should have the capacity to geocode it here. We are developing that, the geocoder, and hopefully it should be ready. So when it is ready, we will let you know. Certainly, and these, as I said, that industry cluster, occupation cluster, all these websites are continuously under development. So we are trying to develop new tools and testing those new tools. And then some additional data, the regional food hubs, the community supported agriculture. I mean, these are difficult data sets. I mean, these are new types of infrastructure. People are still gathering information. So as we get it, we will try to put it here. So I hope that answers your question. Any other question?
And I want to add two new words that the farmers market database updated on USDA website once in 2 weeks, but we plan to do this update probably on annual basis, because it takes also some time to clean this database. Some data become obsolete and so on. So it takes some time. So we will do it on annual basis. And if everyone wants to add farmers market, and we can work with Indiana, whoever is in Indiana, we can add this straight to the database, this information.
Yeah, thank you, Andre. Yes, that option is there. So because you are regional consuls of Indiana and you have some specific data, you want to see it for your region, we can build it onto this database. However, if you want to have data which only you can see, then you should use your upload shapefile tool. Means many times you deal with confidential data set or some sort of like plat boundaries or things like that, or brownfields, then this upload shapefile tool will be useful, because then you can upload, only you see that, it remains on your desktop, and then you work with that, you analyze with that. No one else can see that data, including us. It does not come to our server. Any more questions? Anything? So the next webinar will be on processed food movement. We call it food logistics, but it's an emerging area. There is quite a bit of research happening at different universities, and we are also trying to develop some of our own tools. One area that we will be focusing on future, that is on our target, is developing tools or developing at least some models for food shed delineation, and that's an interesting topic. Then we go into the area of optimization, transportation, and regional linkages and things like that. So with this, thank you for your time, and please go and spend some time with the exercise. That will just give you some practice to use, or start using RDM website for your own project. And please give us feedback, because when you give us feedback, we are able to improve it and make it as user friendly as possible. That's the purpose, that it should be used by regional planning commissions. With this, since there is no question, we will be ending this webinar. Thank you for your time. Thank you.